Good afternoon, students. Today we're going to see about the application-oriented problem in the development of surfaces, that too, especially in engineering drawing process. Before going into the application part, I want to discuss about what are all the things that you know based on the development of surfaces. Whether you guys have experienced the workshop practices lab. Yes, very good. In the workshop practice lab, you have done a part on sheet metal work. What are the experiments that you have done on sheet metal work?
Rectangular tray and square tray.
Rectangular tray, square tray, and code. These are the experiments that I have done in the sheet metal work. How come you cut the requirement of sheet metal work for the square tray and rectangular tray? In what way you have calculated, and how come you have calculated and cut the sheets for the requirement dimension?
First of all, the calculator.
Yeah, very good. Very good.
In the measure the required dimensions and we cut it into the required dimensions and fold the part.
Good, very good. For the development of surface, when you develop the entire surface, it is based on the perimeter or circumference. When it go for the cylindrical shape, it will be of circumference. When it go for the edges with sharper edges, then we go for the perimeter. For a perimeter for a square is 4a. Perimeter for the rectangular is 2l into 2d. That is the formula that you will need to calculate. This is how the real-time application works. When you go for the real-time application of development of a chimney, we're going to see it in detail. Here, a vertical chimney of 70 centimeter diameter joins a roof, sloping at 35-degree inclination with the horizontal. The shortest portion of the roof is 32 centimeter. Obtain the shape of the sheet metal with the chimney can be fabricated. So the chimney is of 70 centimeter diameter. What do you understand from this?
The shape is set.
Yeah, very good. The shape is of cylindrical. Are we able to design a chimney of 70 centimeter diameter? Is it possible to draw 70 centimeter? Is that possible? You just think of that. Then what we have to do? Centimeter to millimeter. Yeah, we have to reduce the scale. So we have to reduce the dimension. So here we have to apply the concepts of reducing scale. When we go for applying the concept of actual dimension, then it is actual scale. When we go for the reducing the dimension, we call it as reducing scale. In some cases, we have to draw for the enlarged dimension. That is called as the enlarging scale. Okay. Then now we will see about the exact procedure. As I said that, now we're going to see how the question can be explained in detail. Here, on the top of the roof, a chimney is kept. The shortest portion over the roof is 32 centimeter. This is the shortest portion. This is the shortest portion. The shortest portion of the roof is 32 centimeter. And it is an inclined angle of 35 degree. Here, we have to calculate how much material is required to fabricate this chimney. The chimney given is of cylindrical shape. This is the front view of chimney when we draw it in separate mode. So this is the chimney is in of cylindrical shape. So cylindrical shape. So the upper portion of the cylinder is developed here. We have to develop the upper portion of the cylinder. The lower portion of the cylinder can be cut out. The sheet metal work, in the sheet development of sheet metal work, the lower portion of the sheet metal can be removed. Let's see how we have done. We are using the reducing scale to draw the concept. First, in the first step, we just draw the circle, and now later on we have to divide the circle into 8 equal parts. For dividing the circle into 8 equal parts, we have to take 45 degree for each part. We have to draw this. And then the outer circumference line of the cylinder. The outer edges have to be drawn in the thick line, drawn as thick line. Then we have to draw thin lines for equal parts that we have divided here. We can give the notations in alphabets for the upper portions, and for the lower portions we can numbering. And the 35 degree. Now the chimney is inclined at 35 degree on the rooftop. So I'm just drawing an inclined line of 35 degree. We can imagine it as a cutting plane from this corner. Later on, we have to develop this surface. For developing this surface, I have to calculate the circumference of the circle. By using the circumference of the circle formula, we have to develop that. 5 into 35. For this dimension, we have to draw the line. Then, for dividing this line into 8 equal parts, either we can go for different methods. I can draw a line of 80 centimeter, 80 mm, inclined at any degree, and then you divide it into 8 equal parts. Then 8th part and the last line have to be drawn here. Similarly, we can draw the parallels. Likewise, we have to draw 8 equal parts. Then we have to mark the cutting portions. Here, for the A dash to A1 line, a point is here and the similar one point is over here. For the 2, the point is here and the end point is over here. The 3, the point is here and the end point is over here. For 4 and 6, 5. Then we have to draw a curved line to join us. This is how we have to develop this form. Thank you.